You can buy a Tesla with Bitcoin, but you can't really buy a coffee. For years, this has been the fundamental contradiction at the heart of the world's most famous crypto. Bitcoin's whole point, its original promise, was to be a peer-to-peer electronic cash system. Yet for small daily transactions it remains painfully slow and can be shockingly expensive. Waiting 10 minutes for your latte to get confirmed just isn't going to work. But what if that's all about to change? What if a new wave of thinking is about to make Bitcoin actually useful for, buying things? To get why we even need a solution, you have to understand how Bitcoin is built. The network is designed for ultimate security and finality, not speed. It processes transactions in batches called blocks, and a new block only gets added to the chain roughly every 10 minutes. This process, known as mining, is what makes the network so secure, but it also creates a deliberate bottleneck. The entire global network can only handle about 7 transactions per second. When a lot of people try to send Bitcoin at once, that limited space creates a digital traffic jam. To get your transaction included in the next block, you have to outbid everyone else by paying a higher fee. Sometimes those fees can be several dollars, meaning your $3 coffee suddenly costs $8. This combo of long waits and wild fees has been the single biggest hurdle stopping Bitcoin from being a global currency for everyday shopping. It's brilliant as a store of value, like digital gold, but it's struggled to be practical digital cash. Now, this isn't a new problem, and for years, the leading solution has been the Lightning Network. The Lightning Network is a Layer 2 protocol, which just means it's a system built on top of Bitcoin. Think of the main Bitcoin blockchain as the high-security Supreme Court for settling huge, important disputes, while the Lightning Network is like a handshake deal for handling day-to-day business quickly. It lets users open payment channels with each other where they can fire off countless transactions, almost instantly, for fractions of a cent. And Lightning isn't just a theory, it's a real growing ecosystem. By late 2025 it was already processing well over $1 billion in transaction volume every month. It's seen major adoption, with big exchanges integrating it and countries like El Salvador using it to make Bitcoin a practical payment option. In many cases, payment success rates are over 99%, with speeds of less than a second. For a lot of people, Lightning is the answer. But in crypto, the innovation never, ever stops. And the quest for perfect scaling has led to some very different ideas. So, what if there was another way? A path that didn't involve the complexities of opening and managing payment channels. This brings us to a new conceptual model for scaling Bitcoin, a hypothetical project we're calling Bitcoin Everlight. Now let's be clear, this isn't a live project you can invest in today. Think of Everlight as a fascinating case study, a blueprint that explores a different way to get to the same goal, making Bitcoin fast and cheap for everyone. This conceptual layer is designed as a lightweight transaction system that runs alongside Bitcoin, without changing any of its core rules. The idea is to create an express lane for transactions, but with a different set of traffic rules than the Lightning Network. It's an attempt to find a middle ground, offering speed without some of the hands-on liquidity management that comes with payment channels. So, how would a system like this actually work? The core idea behind the Everlight concept is to separate sending a transaction from a transaction settling. Instead of broadcasting your payment to the whole Bitcoin network and waiting for a miner, you'd send it to a dedicated network of Everlight nodes. These nodes would be responsible for lightweight verification, quick checks, like making sure the signature is valid and putting transactions in the right order. Confirmation wouldn't take 10 minutes. Instead, it would happen in seconds through something called quorum-based validation. That just means a transaction is considered confirmed once a small group of nodes all agree it's valid. This creates a two-tiered system. Everlight handles the fast, high-volume traffic of everyday purchases, while Bitcoin's main blockchain remains the ultimate source of truth for security and final settlement. To keep it all tied to Bitcoin's legendary security, batches of these transactions could be anchored to the main blockchain, creating a verifiable record without clogging it up with every single coffee purchase. To make sure everyone on this network plays nice, node operators would have to stake a native token, we'll call it BTCL, as a security deposit. In return for their good behavior and performance, they'd earn rewards. In this model, there are even different tiers of nodes: light, core, and prime, with the higher tiers taking on more responsibility for a bigger slice of the rewards. No decentralized network works without a solid economic plan, or what we call tokenomics. For our conceptual project, the BTCL token is the fuel for the whole system. This hypothetical model proposes a fixed supply of 21 billion BTCL tokens, designed to be predictable and non-inflationary within its own ecosystem. The token allocation is all laid out in advance. In this blueprint, 45% would be for a public presale to fund development, 20% for rewarding the node operators, 15% for making sure there's liquidity on exchanges, 10% for the development team, unlocked over time, and 10% for a treasury to fund future growth. The presale itself would be structured in phases, with the price gradually increasing from a starting point like Southboss and Orate. The token's utility is baked right into the network. It would be used for paying tiny transaction routing fees and, as we mentioned, it's what operators stake to participate in the network. This creates a self-sustaining economy where the token's demand is directly tied to how much the network is used and secured, a common and powerful model for launching new crypto projects. So you have the Lightning Network, which is real and working today, and then you have concepts like Everlight. Why is the crypto world so obsessed with finding new ways to scale? A big part of the answer is the sheer scale of the potential demand. The approval of Bitcoin ETFs opened the floodgates to institutional interest, creating what some people see as a multi-trillion-dollar demand gap that the base network just can't handle. This has put a laser focus on building better, faster layers on top of Bitcoin. The Everlight concept represents a different architectural choice compared to Lightning. While Lightning builds a web of peer-to-peer payment channels, the Everlight model suggests a system where nodes broadcast and validate transactions by consensus. Neither one is necessarily better. They're just different engineering philosophies trying to solve the same problem. The fact that these different ideas exist shows a huge evolution in the crypto space. The conversation is no longer about messing with Bitcoin's core rules. That's considered settled and secure. All the real innovation is now happening on layer 2, the application layer, where developers have the flexibility to experiment with speed, cost, and user experience.